right, Section 2, Chapter 3, Derivatives of Logarithmic Functions. The natural log, ln, not to be confused with a voice actress who plays a blue tang in a movie called Finding Nemo and Finding Dory. ln is the natural log, comes from e to the x. It's the inverse of e to the x. We'll talk about that guy in Section 3, but here we are in Section 2 talking about the logarithmic function ln. Simply put, the derivative of ln of x is just 1 over x. So we're going to do 4 problems based off of that very simple fact. A lot of the problems we'll do probably has chain rule involved, maybe a quotient rule here and there, but a very quick section, shouldn't take long at all. Let's get started. Alrighty, we are going to do 4 problems, I think, in this section, and they're all very much related to each other. I guess you could say they're derivatives of each other. Ha! Pun intended. Let's get started. Remember, simply put, the d dx, the derivative of ln of x, is 1 over x. And I guess maybe a way that we can view this is the derivative of ln of stuff. I don't know why I put ln. ln of stuff is 1 over stuff. Now that might seem dumb, like why put that there? Well, that's going to help us when we try to understand the chain rule with these types of problems. Most of these are chain rule. If you look at A and B, we have functions within functions. Okay, the outside function is ln and the inside function is something else. And that's probably going to be the same case with the other 2 problems, but we'll get there when we get there. So I have a function within a function. My outside function is ln. So you take the derivative of the outside stuff. Okay, so that becomes 1 over stuff. Keep the inside stuff. Okay, so my derivative of ln is 1 over stuff. So you keep that stuff times the whole thing by the derivative of the inside stuff, and the inside stuff is 2x, so the derivative of that is just 2. And you end up with 2 over 2x, because 2 times 1 over 2x is 2 over 2x. Cross out the 2's and we just end up with 1 over x anyway. So if that's a 3, if that's a 4, if that's a 5, if that's a 6, we're just going to get 1 over x regardless. Okay? So the next problem is going to be a little more complicated. But we have the space, we have the time. Let's get going. The derivative of ln of stuff is going to be 1 over that stuff. So x minus 1 over x. And we're going to multiply the whole thing by the derivative of the inside stuff. Well, the derivative of the inside stuff, I could do quotient rule. But do I want to do quotient rule? Yeah, let's just do quotient rule. I'm going to let u equal x minus 1. I'm going to let v equal x. So u prime would be 1. V prime would also be 1. And v squared would be, what is it, x squared. So I'm going to multiply the whole thing by the derivative of the inside stuff, which is u prime v, so 1 times x, minus v prime u, which is going to be 1 times x minus 1 over x squared. All right, so fun fact. If you have 1 divided by a fraction, you're allowed to take the fraction and multiply the top by the reciprocal. So this just becomes x over x minus 1. The first part becomes x over x minus 1 because 1 over a over b is b over a. I'm going to simplify this to 1 times x, which is x. Distribute the negative 1 to x, so you get minus x. How convenient. And distribute the negative 1 to negative 1, which becomes positive 1 over x squared. So this goes away. And I'll need the plus 1 there, or the plus, I mean. X times 1 is x on the top over x squared times x minus 1 is going to be, we'll tell you what, let's not do that. Let's do this. Let's just leave it as x squared right now times x minus 1 because I have 2 x's down here and 1 x up there, so that kills off and I'm left with 1 x down there. So this just ends up being 1 over x squared minus x after I distribute 1x to x minus 1. Okay. So if you haven't noticed, the pattern of these problems is we're probably going to have to do 1 over stuff and then multiply the derivative, which you're not incorrect in saying that. So I have the derivative of this guy so far is going to be 1 over the square root of x. So you take the derivative of the outside, which is 1 over stuff, but keep that stuff there and multiply the whole thing by the derivative of the inside. Okay? The inside is square root of x. I'm going to view it as x to the 1/2. So when I multiply everything times x to the 1/2, for the derivative of x to the 1/2, that becomes 1/2 x to the negative 1/2, which looks like this. 1 over root x. Since that's a negative exponent, I have 1 over 2 x to the 1/2 on the bottom, which I know is just square root. So 1 times 1 on the top is 1. 2. The square root of x times the square root of x is the same thing as the square root of x squared, or just x. That's that. There's a song, I forget who sings it, sometimes we save the best for last. Well, we didn't do that here. The worst is the last one. That's all right. I believe in us. I believe in all of us. F prime of x is going to be the derivative of the outside stuff. Keep the inside stuff. Cos x over 2x minus 1. Multiply that to the derivative of the inside stuff. Again, we have quotient rules. So I'm going to let u equal cos x. I'm going to let v equal 2x minus 1. U prime is going to end up being negative sine x. V prime is just 2. And v squared is going to be 2x minus 1 squared. And I'm not going to FOIL that out yet, just in case things simplify. So the derivative of the inside stuff ends up being u prime negative sine x times v, 2x minus 1, minus v prime, 2, u cos x. All over 2x minus 1 squared. Remember, if I have 1 divided by a fraction, you're allowed to flip the fraction and move it up. So this becomes 2x minus 1, and I'm going to throw that in parentheses because of that, over cos x times, let's distribute that. 2x times negative sine x is negative 2x sine x minus negative, so plus sine x minus 2 cos x. That's technically all in parentheses too, where I should have maybe put a bracket, but it's too late. 2x minus 1 squared. One of you go away, one of you go away. And I'm not sure any other magic happens. I don't see it. So it's just all a matter of putting it all together. The entire top is negative 2x sine, not cosine, sine x plus sine x minus 2 cosine x all over, if I distribute that, I get 2x cos x minus cos x. Gross. Not that bad, though. If you look at it, you're like, that's not so bad. I can handle that. And that's pretty much the section. I mean, it's all the same type of problem. If you have ln of stuff, you just take the stuff, put it on the denominator, and then multiply by the derivative of the stuff. Not too bad. All right, that's the end of that section. Bye.